So we're continuing lesson 2 with quadratic functions, and we skipped one last time, so we skipped number 4. So this is one that also talks about like maximizing revenue and so on. We've had questions like that before on the homework, so we're going to continue to talk about it. So it says a popular video game will be released at GameStop in a week. The store has determined that their revenue for the month will be R of P equals negative 25P squared plus 1200P, where P is the price per game in dollars. Okay, so it says find the revenue earned for each price listed. So what I'm asking you to find is R of 20, R of 25, and R of 30. So we're going to plug in 20, 25, and 30 using our calculator. All right, so you can, on your main screen, just plug them in. So you're going to have negative 25, and you're going to do 20 squared plus 1200 times 20. What are you guys talking about? So we're plugging it in, and we get 14,000. It's not a hard question. You can do this. You're just plugging in numbers into this section right here. What are you guys talking about? All right, so you're putting in each of these numbers in for P, for the price. Did you guys do that? And you get 3 different answers. And we do the last one. What did you get for the 30? No one? Close. 13,500. Yep, so what does it look like the price is going to be somewhat close to? 25, right? That looks like the one that's giving us the most money. That's what we want. We want to price our game perfectly so we get the maximum revenue that we can possibly get. Let's think about this in real life. If I price my game too high, what happens? Less people buy it, right? So they're finding the game at another store for a cheaper price. Okay, what if I price it too low? It's too low, there's more people buying it, but the price is too low, it's never going to reach that maximum amount. So you have to find that perfect price for any kind of thing that you're creating. So this is a very important concept when you get into calculus, right? This is the whole reason calculus was pretty much invented, to find maximums and minimums and so on. So businesses use calculus all the day, all the day, every day. They want to all the time. They want to find the maximum profit. They want to find minimum cost. They want to find the best thing for their business. So this says find the price per video game that will yield the maximum revenue. So we're seeing the word maximum. So that means that we have a downwards parabola with the maximum, the vertex at the top. So we find that by doing x equals negative b over 2a. So in this case, it's not x equals, we write p equals. So p equals negative b over 2a. So we get negative 1200 all over 2 times negative 25. So when we divide it out, we get 24. So what this means is we should charge $25 for each game, or $24, sorry, for each game. And then the next question says, well, what is the maximum revenue? So what do we do to find the maximum revenue? Yeah, plug in that 24. So we have R of 24 is equal to, I'm just going to do second enter. It pulls up that last equation, and I'm going to change all my 30s to 24s. So it's a little bit more than $25. It was $14,400. So that's the price. Does that make sense? All right, so we talked about the quadratic formula a little bit last time. Hopefully you guys remember that formula. And there's lots of cheesy songs that you can memorize it to. Did you guys memorize it to some cheesy song? Yeah, we watched the music videos last year. There's the Get Low one. There's lots of different things. All right, so we did do number 5, but we didn't do these other ones, right? Didn't I skip these or something? All right, so let's do 6 and 7. You guys are like, no, don't erase. All right, so 6 and 7. All right, so number 6, so solve the equation. So I have 3 times x minus 1 squared. So I'm going to do x minus 1 times itself minus 4 times x plus 2 equals x times x minus 5. So I'm going to have 3, and I FOIL. So I'm going to have 3 x squared minus 2x plus 1 minus 4x minus 8, right? Make sure you distribute the negative 4 to both of them. x squared minus 5x. So I have 3x squared minus 6x plus 3 minus 4x minus 8 equals x squared minus 5x. So I'm going to get everything on one side and I'm going to factor. Right? So I'm noticing that I have x squared and x's, so I usually need to get equal to 0. So I'm going to have 2x squared. I'm going to add my 5x over and get negative x. Oh, hang on, negative x and then negative 4x, right? So negative 5x. And I have 3 minus 8 is negative 5. And try as you might, it does not factor. So we do the quadratic formula. So I get negative b plus or minus the square root of b squared minus 4ac all over 2a. It never fails. It doesn't matter what class I'm teaching. In my AP Calc class too, everybody's like, oh, I'm like, oh, it's really not that hard. I'm like, it's not a hard formula, right? Too long. All right, so I have 25 and I do plus 40, so I'm going to have 65 over 4. So I have 5 plus or minus the square root of 65 over 4. So if we start thinking about whether or not 65 can reduce out the square root, right, it breaks into 5 and 13. 5 and 13 don't have perfect squares. So we're done. This is the exact answer. All right, now if I say round to 3 decimal places, then you would just put that in and you would say, okay, I'm going to have 5 plus the square root of 65. I put that all in parentheses, and then I divide by 4. So the first one would be 3.266. And then when I do a minus, you get negative 0.766. All right, those would be the rounded answers. Yes? I usually prefer the exact answer. But on the AP Calc exam, that's kind of like nice when I'm teaching Precalc, because I can kind of train you all this year to do well in the AP Calc exam. The AP Calc, they round to 3 decimal places or do the exact. So either form would be accepted. Okay. All right, and number 7, so it says the parabola intersects the line. So the first time we talked about intersection points was when we talked about a line intersecting another line. Okay, and we did that with 3 different methods. We graphed the lines, right, to find where their intersection point was, and we hoped and prayed that it was a nice point that we could tell if it was something with a fraction or decimal that was rough. All right, we could use substitution or we could use elimination. You know, all those methods. This is the same idea. So it's kind of like we have a system of equations. We have negative x squared minus 3x plus 4, and we're combining it with y equals negative x minus 1. So we can't really do elimination very easily because we can't just add straight down and line up x's and y's like we had before. But we can do a substitution. So if we want to replace y, we can replace it with negative x minus 1. So it's basically like you're setting these 2 equations equal to each other, right? So you're going to have negative x minus 1 equals negative x squared minus 3x plus 4. So this is the one that you might have had trouble with on your homework because you hadn't done it yet. All right, so we're going to add the x squared over. We're going to add the 3x over and have plus 2x. And we're going to subtract the 4, so we get minus 5 equals 0. And we can try to factor. It does not factor. So we do the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Does that make you do quadratic formula? I hate you. I also have very good ears. I can hear you guys. All right, 24. I always hear all the good gossip while I'm sitting at my desk, and you think that my ears turn off. Oh, I've heard lots of things. All right, not this year. It's been like 2 days, 3 days. All right, so square root of 24. So 24 breaks into 2 root 6. Yep, 4 and 6. So you're going to have plus or minus 2 root 6 all over 2. This is where you do your fancy heart thing. Oh, yes. So you notice that all of them have a common factor of 2. So you divide by 2 everywhere. So you get negative 1 plus or minus 1 root 6, or just root 6. Okay, so you get, if you wanted to find the decimal answer, maybe I should do an approximately sign. So if you do negative 1 plus root 6, you get 1.449. And if you find the other one, -1 minus root 6, you get -3.449. So the hard part about this is I did not just ask for the x value, I asked for the intersection point. And that's hard, because now you have to find the y value that goes with them. So you know it's 1.449 comma something, and you know it's -3.449 comma something. But I gave you a whole lecture last year about how you should round early. Right? You should always keep those answers and then plug them into something else. So you should probably like store them, or if your calculator lets you go up and grab one, make sure you're grabbing it, don't just round. So I'm going to use that -3.449, and I'm going to find the y value by doing negative answer -1. The y value is 2.449. And then I'm also going to do my -1 plus root 6, so I'm going to find what that answer is again on my calculator, so I haven't rounded, and then do negative answer -1. So -2.449. Does that make sense? You go back and find them. Were they both the same y value? I don't remember them either. Oh, I guess they're opposite. All right, so now let's talk about using our calculators. All right, so this fancy program here, we're going to use it. All right, so let's say that I know. Let me go back to my standard window. This was something I did in calc, so I got to get rid of it. It is free. Yes, you can get this for your computer if you would like to. It's under Wabbit, like rabbit with a W. So you can look up Wabbit if you would like. All right, it's a little annoying though when you're typing things into your computer, because I literally have to like type in every single thing. So I'm going to put in the first thing is negative x squared, and go ahead and do this on your calculator as well. So x squared minus 3x plus 4. And then I'm going to put the other one, which was negative x minus 1. Okay, notice when I started out the equation, I actually used a little negative sign. I did not use minus. I used negative. All right, so when I hit graph, it shows a parabola and a line, like it should, right? It doesn't? What does yours show? All right, if you need the standard window, so if yours does not look exactly like mine right now, you probably have a weird window. So the quickest way to change your window to like the standard x value is -10 to 10, y value is -10 to 10, is to go to zoom. So hit zoom, which is in the middle at the top, and then select number 6, the standard window. So it puts it -10 to 10, -10 to 10. I did download this calculator, yes. It was free. I'm telling you, guys can do it for free. Isn't it exciting? Oh, do you get to use your computer on your test? No. Yeah, I'm sure your math teacher in college would love that. You just open up your computer. All right, so we need to find the intersection point. So basically, any operation that you probably need in this class, most of them, are going to be found under second calculate. So we're going to hit second, and calculate is where the trace button is. So I'll often say second trace. So we're going to hit that. And what we're trying to find in this example are intersections. So we're going to go down to number 5. Good job. Or you can just hit 5 and it will do it. Trace is where it's like the 4th one along the top. All right, so now what we're going to do is we're going to use the cursor. So we're using the left and right buttons. Do you guys see what I'm hitting? Left and right buttons. And let's go to the one on the left. So you're going to trace along the parabola, which was my first curve. And I'm going to go to where I think the intersection point is. And I'm going to hit enter. But now it says second curve. Well, when I move to the right and the left now, I'm along the line. So I hit enter again. And then when it says guess, you get as close as possible to where you think it is and hit enter again. When it says intersection, that is your answer. So was that one of our answers? -3.449, comma 2.449? It was, right? We have that answer. We like this, don't we? All right, so let's find the other one. So we're going to go back in and we're going to do second trace. And again, we're going to do option number 5, intersect. And we're going to trace along the parabola until we get to the place where we think the intersection point is. Hit enter. And then we're going to trace along the line and hit enter. And then we're going to hit guess. All right, and the other point says 1.449, comma, negative 2.449. I don't know. I'm going to have to like reset your memory menu. Or highlight the equal sign. Highlight the equal sign and see if that will come up. Is that deselected for some reason? No. Sometimes calculators do that, and I just have to reboot them. All right, so that's how you find an intersection point. Pretty straightforward. So we do second trace, intersection. Okay, so let's talk about how to find a max or a min. Okay, so we had one on the other page. So let's flip back. Well, actually, let's do this first one, number 5. So number 5 says, use the quadratic formula to find the x-intercepts of the parabola. Okay, I know we did that one last class. But if we're finding the x-intercepts of a parabola, we're going to go into our calculator, hit y equals, and we're going to clear it out. So clear out the first one, and clear out the second equation. Then we're going to put in that 9x squared. So 9x raised to 2 minus 6x minus 11. Oops, no one told me I was doing that. Oh no. Sometimes it's a little different than my calculator. So minus 6x minus 11. Okay, we're going to hit graph. And so we have a parabola, and it's a parabola that goes upward. But in the standard window, we can't see quite all of the parabola, right? We're missing the most important point, which is the minimum. So if you wanted to kind of adjust it so you could see the minimum, you can. You can do that by changing the window. So if you want to ever change the window, here's how you would do that. You would hit window, which is the second button along the top. And it talks about the x values and the y values. So personally, I think like the x values are probably fine for this one. Let's just change the y's. And what we wanted to do is go down further. We wanted to go down instead of going back to like negative 10, let's make it go to negative 20. So we're going to change that to negative 20. The y minimum, the y value, yep. So we're going to change it to negative 20. So the x's are the same, y min is negative 20, and the y max will keep us 10. And when we hit graph, now we can see more of our parabola. So see how we can see the bottom of the parabola. Okay, that didn't really matter for this first thing that I'm asking you, which is to find the x-intercepts, but it will matter if I ask you to find a minimum, which we'll do in a second. Okay? So if I want to find the x-intercepts, I do second calculate. And an x-intercept, another word for it is a 0. So I want to find a 0. So option 2. And we're going to find the thing on the left side. Okay, so here's the thing that's weird about this. So if I zoomed in really far to see what was going on, I'm trying to find that x-intercept. I want to first get something on the left of it. If I'm on the left of that x-intercept, am I above the axis or below the axis? I'm above the axis, right? I'm like around here. That would be a left bound, as we call it. Right? If I want to find something that's a right bound, something on the right of it, I'm below, right? So it's going to ask me to find the left bound and the right bound. Okay, so when it says left bound, I want to get on the left of what I'm trying to find, but as close as possible, as close as I can, okay? So notice how my y value is 0.625 here. That's good. That means I'm above the axis. That's what I want. So I'm going to hit enter. Now a right bound, I need a negative value for the y. So I'm going to go to the right. Notice how I'm below the axis. I'm going to hit enter. And then the guess, you can just go to whichever one you thought was closer. It doesn't really matter. So hit enter. So when I do that, it tells me that my answer is negative 0.821. So if you go back and you check, whoops, where was it? Negative 0.821, we had that as one of our answers. Does that make sense? All right, so let's say we want to find the other one. So we do second trace again, and we find the 0, so option 2. Now when I do left bound, is it above or below? It's below. Do you guys understand that concept? So we hit enter for left bound when we're below. Right bound is above. How do I know for sure that I'm above right now? I'm not really sure. Look at the y value. The y value is positive, so I know I'm above. And then my guess, that looks pretty darn close, so I'm going to hit enter. So notice how now we get 1.488. That was my other answer. Does that make sense? Can you all do this? All right. So now if I want the minimum. No, it's a lot of calculator stuff. The minimum is in the same location. You're still going to do second trace. So second trace. You see the option that says minimum. So hit enter. And it still says left bound, right bound. But I'm not doing the x-axis, right? I'm not finding the zeros. I'm finding the minimum. So what it's saying is get really close to the minimum point, the lowest point, but get on the left side of it. Okay, so when I do left bound, you guys see where I am? I'm like around here. You know, I can hit enter there. And then when it says right bound, I just get on the other side, hit enter. And when I say guess, get to exactly where you think it is. Oh no. Oh, I missed it. All right, I'll do it again. I clicked too fast and it went away. Minimum. And I think your calculator actually has a bit of a rounding error on this. You know, calculators lie to you sometimes. Calculators don't always tell you the truth. This is an instance where it's lying to me. It's saying 0.333333605. Did you guys have that same number? No. You got a bunch of threes? All threes? Yeah, that one's actually telling the truth then, for the most part. Right? 0.3 repeating, what is it? 1/3, right? This is probably 1/3, but your calculator sometimes can't handle all of the digits. So it's like holding it in its memory as it's doing left bound, right bound, and so on. And sometimes it can't handle all of it and it rounds. So this is one where it's probably 1/3, -12. So this is why the AP Calc exam allows you to round to 3 decimal places. Because if you're not sure it's 1/3 and you're like, ooh, I don't know what to do. Is it really 1/3? You know what I would do? I would write 0.333, right? Because then it's right. They counted it correct. Make sense? So that's going to be your minimum for that one. Okay, so are we good on all the calculator stuff? All right, so you guys have a few minutes. You guys can go back and do the one that we kind of didn't do on your homework if you would like to.